Assalamu
Balaji.
alaikum.
Walaikum salam. How are you?
Alhamdulillah, great. How are you all? How's everyone?
Doing good.
Everything's good.
Doing good,
Thank you.
Doctor.
You're welcome.
Doctor, we'll wait for another 2-3 minutes, then we'll start the session.
Okay, sure.
Is it okay?
Sure, definitely. Sure, yeah, sure,
Thank you, Doctor.
definitely. You're welcome.
Doctor, shall we start?
Can we? Yeah. Can I start now?
Doctor, I'll record the meeting, the webinar.
Yeah. You're double. Can I start it now?
No, Doctor, I'll introduce you. Just I'll start recording
Okay.
it, then I'll introduce you. Then you miss.
Sure.
That actually this is for our master students. Uh, in 1 or 2 campuses already they are having some other classes, so they are not in a position to join this webinar. So we will record it and we'll share it with them.
Great.
Good afternoon, everyone. This is Dr. Balaji from Salala, UTAS. It's my immense pleasure to welcome you all for the second webinar for the Business Process Automation and Optimization course. I'm happy to introduce Dr. Qamar al-Islam. He's an AI, robotics, and intelligent automation researcher and educator with a PhD in control and automation, with a specialization in robotics from University Science Malaysia, a fellowship of Advanced Higher Education UK, and a Gulf Higher Education member UAE. His expertise spans robotic perception, computer vision, SLAM, AI-enabled automation, RPA, digital transformation, and practical computing education. He has contributed to several funded research projects in AI, drones, IoT, educational technologies, autonomous systems, and intelligent automation, and has published in QN, Scopus, Web of Science, and JCR international journals, with Google Scholar citations reaching around 498 with an 11 high index. Dr. Qamar is passionate about guiding undergraduate and postgraduate students through hands-on, research-informed, and industry-relevant learning experiences. Dr. Qamar, we thank you for accepting our invitation and giving a seminar on RPA in business process management. Thank you, and the floor is all yours, Doctor. Please.
You're welcome. Can we share the screen because the option is like disabled? Share a screen.
Yes, Doctor, you can share it. Yeah.
But I cannot share because it shows only meeting organizer and presenter can share. Maybe you have to open the option to share it.
Is it, Doctor?
Yeah. My option is black, like a disabled.
Yes, Doctor. I made you as a presenter. Yeah.
Okay. Can I? Yeah. Share.
Yeah.
Screen. Now you see my screen?
Yes, Doctor. Yeah, we can see.
Okay. And I open it.
Not the PPT. Yeah. Now it has come. Yeah. Thank you.
Yeah. Now you see my screen, Doctor?
Yes, Doctor. Yeah.
Okay. Now, good afternoon, everyone. Thank you very much for joining today's session. I'm very pleased with the postgraduate students at the University of Technology and Applied Sciences, Oman, for this workshop on robotic process automation. We can call it as as extra word, we can call this robotic process automation from a business process understanding to intelligent automation. Okay, this process actually, it is in the business process, identifying repetitive work, designing automation logic, and then thinking responsibly about how technology can support people and organizations. When many students first hear the word robotic, they imagine physical robots, robotic arms, drones, or autonomous vehicles. As someone whose research background is in robotics, computer vision, and automation, I understand why this happens. But today, when we say robotic process automation, we are not talking about a physical robot, right? Walking inside an office. We are talking about software robots that work inside digital systems. These software robots, or we call it as bots, can open applications, read files, copy data, fill forms, send emails, validate records, and prepare reports. The most important message for today is this: RPA is not magic. RPA is structured thinking converted into software execution. A board can only do well what we understand clearly. So before we build a board, we must understand the process. Who start the process? What data comes in? What decision rules are applied? What happens when information is missing? Who approves the final output? These questions are the foundation of professional automation. For postgraduate students, this topic is especially important because organizations today needs graduate who can think beyond one narrow technical tool. They need people who can understand businesses needs, communicate with users, map workflows, evaluate risk, use data, and design technology solutions. So today's workshop will combine conceptual understanding, technical explanation, hands-on logic, and responsible automation thinking. By the end of this session, I want to feel confident that you can look at a real process such as student registration, certificate request, invoice checking, HR onboarding, or customer service emails and say, this part can be automated and this part needs human judgment. And this is how we can design it safely. Okay, let's go on. Okay, now a practical business oriented introduction to RPA we can call it as, I want to make our learning outcome very clear. In a in approximate 2 hour session, we cannot become full RPA developers overnight, but we can build a strong foundation. My aim is that we can leave this workshop with practical mindset. You should be able to understand what RPA is, where it is useful, where it is not useful, and how to start thinking like an automation designer. That the first outcome is that you will understand what RPA can and cannot automate. This is very important. Many automation project fails because people become excited and try to automate everything, but not every process is suitable for RPA. If a process changes every week, if decisions require deep human judgment, if data is very messy, or if the risk is very high, then automation may not be the first step. A professional automation specialist knows not only when to automate, but also when to pause. The second outcome is that you will learn how to read a business process and identify automation candidates. For example, imagine a university office receive 100 student requests. Every week, staff members open emails, check student IDs, verify payment status, update an Excel sheet, and send an confirmation email. This is classic process where we can study repetition rules, data quality, and possible automation. The third outcome is to compare major RPA platforms such as UiPath, Automation Anywhere, and Microsoft Power Automate. I will not present them as advertisement. Instead, I want you to understand their common logic. Uh, uh, First, they use trigger, then action, then condition, loop, execute, exception, log, and monitoring. The fourth outcome is hands-on thinking. Even if we do not install a tool on every student laptop today, you will learn how to design simple automation logic. This is very important because tools, buttons change, but logic remains transferable. The fifth outcome is governance. We will discuss security, privacy, human impact, and accountability. A board that works technically but creates a risk is not a successful board. Professional automation must be useful, safe, measurable, and human centered. So today we are not just learning tool names, we are learning how to think, design, and evaluate automation responsibly. Now, this is the foundation model. In this, what we do actually, our journey of today's workshop, I want you to see the structure before we enter the technical details. The workshop is, or webinar is divided into 6 connected parts. The first is foundation, then tools, business process, hands-on logic, governance, and roadmap. This sequence is intentional because we start with meaning, then move to tools, then process, then practice, and finally responsible implementation. Okay, these how we work it, and we are covering what is RPA, what is bot, how is RPA different from AI, BPM, APIs, macros, or physical robotics. This foundation will present confusion later. These are the tasks. For example, 3 to 3:20, we are covering about RPA fundamentals. In this part, we will answer basic but important questions. What is RPA? What is bot? How is RPA different from AI, BPM, APIs, macros, or physical robotics? This foundation will prevent confusion later. Then we move on later on for example, from 3:20 to 3:45 approximately, we look at tools and bot concept. Then we go for BPM and hands-on automation design. Then we go on governance and modern architecture. Then in the last, we go for automation opportunity canvas. And then in the last, we go for question and answer session. Okay, now, okay, this is the basic question. What is RPA and where it fits, why it matters? Okay, now we begin part 1, the foundation of RPA. Before discussing tools, we must first build conceptual clarity. In my teaching experience, students often become more confident when we first remove ambiguity. So let us begin slowly and clearly. For example, now RPA stands for Robotic Process Automation. The word robotic can be misleading because, as I mentioned earlier, RPA does not usually means physical robots. In this context, the robot is a software bot. It performs digital tasks by following instructions. It can interact with applications in ways similar to a human user, clicking, typing, copying, pasting, reading, validating, and submitting information like a human do. The word process is equally important because RPA is not about automating one random click. It is about automating a sequence of work. For example, a finance department may receive invoices, right? Check vendor details, compare amounts, enter information into an accounting system, and send a confirmation. That entire chain is a process. Before we automate, we need to understand the process. The last word, automation, means the board performs certain tasks without needing a human to repeat every action manually. But automation does not mean human disappear. In professional settings, human still design, supervise, improve, and handle exception. In fact, good automation often makes human work more meaningful because people can focus on judgment, service quality, analysis, and improvement. Now, why does this RPA matter? It matters because many organizations still depend on manual work between digital systems. Even advanced institutions may still have staff copying data from emails to Excel, from Excels to portal, from portals to databases, and then generating reports. This creates delays, errors, fatigue, and inconsistency. So in this first part, I want you to understand RPA as a bridge. It connects existing systems and improves routine work without always requiring a full system redesign. But we must use it carefully. The strongest RPA professionals are not those who click fastest in a tool, but those who understand process deeply. Now, okay. What is robotics process automation? It will include software robots, digital tasks, and rule-based work. Okay. Now, what is this? Let us make this very simple. Okay. Now I take the example. Imagine a staff member receives an Excel file. Staff member receiving an Excel file every morning. For example, 8 a.m. They open the file, check which rows are complete, copy the information into another system, send emails to approved cases, and prepare a daily report. Okay, if this task follows a clear rules and happens repeatedly, then a software bot can be trained or designed to perform many of those steps. The second point is that RPA is strongest for repetitive, structured, high volume task. Repetitive means the task happens again and again. Structured means here the data is predictable, such as rows in Excel, standard emails, forms, or database entries. High volume means there are many cases, so automation can save significant time. For example, processing 2 records per month may not justify automation, but processing 2,000 records per month could be a strong candidate. The third point is very important. RPA often connects systems without changing the legacy applications underneath. Many organizations have older systems that still work, but they not connect easily through modern APIs. Instead of replacing the entire system, RPA can operate through the user interface. It can open the old system, enter data, extract results, and update another file. This is why RPA is sometimes called a bridge technology. The fourth point clarifies that RPA is not physical robots. For a student from robotics or engineering background, this distinction matters. In physical robotics control, we deal with motors, sensors, navigation, control, and perception. But in RPA, we deal with software, workflows, business rules, digital forms, data validation, and system interaction. But both fields share one common idea. Automation requires clear sensing, decision making, action, and feedback. A useful phrase here we can use that RPA is digital worker for routine screen based work. But like any worker, the boards needs instructions, permissions, supervisions, and quality checks. If the process is unclear, the board will also behave poorly. So our first professional lesson is simple. Before building automation, understand the process. Now, why RPA matters now? Automation as a core layer in digital transformation. Why RPA is relevant today? Because organizations are under pressure to become faster, more accurate, more digital, and more responsive. But most organizations cannot rebuild all their systems at once. They may have different software applications, old databases, Excel sheets, email-based approvals, web portals, and manual reporting. This creates what we call operational friction. RPA help reduce that friction. The first reason RPA matters is that organization needs faster operation without always rebuilding systems. Full digital transformation can be expensive and time consuming. RPA can provide a practical step forward by automating repetitive tasks across existing systems. For example, a university may not immediately build a new student service platform, but it can automate parts of certificate request handling, attendance reporting, or event registration. The second reason is that RPA reduces manual copy paste rework and processing delay. Many errors in organizations do not happen because people are careless. They happen because people are tired, overloaded, or forced to repeat boring tasks for long hours. A board can repeat the same structured task consistently, provided the rules are clear and the data is clean. The third reason is that AI is expanding automation. Traditional RPA is rule based, it follows instructions, but when we combine RPA with AI, automation becomes more powerful. For example, AI can read documents, classify emails, extract information from PDFs, detect anomalies, or summarize requests, right? Then RPA can move that information through systems. This combination is often called intelligent automation. The fourth reason is employability. Graduate students need both tool literacy and process thinking. Employers do not only need someone who can say, I know UiPath. They need someone who can ask, what is the process and what is the business value? What are the risks? How do we measure success? Where should human review remain? Now, this slide actually start from the manual work, then it go to digital, then automated, then intelligent. How the boards are trained from manual to intelligent. Many organizations are somewhere in the middle. Your role as a future professional is to help them move forward responsibly. RPA is one practical doorway into that journey. Now, uh, now we have some definition: RPA, BPM, APIs, and AI. Okay, this is the important slide because they clear a lot of doubts about these definition. Okay, now, for example, when we think about RPA, actually RPA is a part of wider automation family. The strongest digital transformation solutions combine process understanding, integration data, automation, AI, and human judgment. Let us begin with RPA. RPA works through user interfaces. It can click buttons, enter information, read data, and move across applications. It is very useful when direct system integration is difficult, or when a process already exists and needs execution support. For example, if a staff member manually opens a portal and updates 100 records every day, RPA is helpful in this condition. Now, let's discuss to BPM. BPM stands for Business Process Management. BPM is not mainly about clicking screens. BPM is about modeling, improving, and governing end-to-end processes. For example, a student admission process may involve application submission, document verification, payment checking, academic approval, notification, and record creation. BPM help us understand the whole process, not just one task. Now, APIs are another important part of the family. An API allows system to communicate directly. If a student information system can send data directly to a finance system through an API, then that is usually more reliable than a board copying data from one screen to another. So the professional principle is use APIs where they are reliable. Use RPA where interface-based automation is practical option. Now, AI adds intelligence. AI can classify documents, detect patterns, predict outcomes, interpret language, and support decisions. However, AI also introduces risk. It may make mistakes, produce uncertain outputs, or require human review. So AI should be used carefully, especially in sensitive processes. The best strategy is written clearly on the slide. Do not force RPA everywhere. Select automation method that fits the process, risk, and system architecture. This is exactly what a selection committee or industry partner wants to see, not tool excitement, but mature judgment. For students, remember this practical rule. If the process is broken, improve it. First, if systems can integrate directly, consider APIs. If the task is repetitive and screen-based, consider RPA. If interpretation is needed, consider AI with human review. Now, uh, we can call it as a board follow instructions like click, read, type, validate, decide, and report. Okay. Here, a bot is not intelligent by default, right? It follows instructions. Think of it like a very disciplined assistant. If you tell it exactly what to do and the environment remains stable, it can perform tasks again and again. But if the screen changes, the data format changes, or the rule is unclear, the board may fail, right? This is why board design must be careful. Now, in this slide, we can show the workflow. For example, first we have a trigger process, then we go for open app, then we go for read data, apply rules, update, record, and send report, the last moment. Okay, now let us take a practical example. Suppose the postgraduate coordinator receives a list of students registered for a workshop. The board can be triggered every morning at 9 a.m. Okay, it opens the Excel file, read each student row, check whether the email's address is valid, check whether the registration status is complete, updates the row as confirmed, send a confirmation email, and finally sends a summary report to the coordinator. This looks simple, but each step requires design. What is the trigger? Is it a schedule an important arrival, or a manual button? What application should the board open? Where is the data stored? What rule defines a valid record? What happens if the email is missing? What happens if the internet connection fails? What should appear in the log? These details separate amateur automation from professional automation. And this slide also lists typical inputs, like, for example, we have Excel, email, PDF, web forms, databases, ERM, CRM screens. These are common in real organizations. Typical output include output records, reports, alerts, logs, and dashboards. Logs are very important because they provide evidence. Without logs, we cannot confidently say what the board did. The key phrase here, we go for good board design, is not magic. It is a clear process logic plus reliable exception handling. For postgraduate students, this is powerful idea. You do not need to begin by memorizing every tool command. Begin by understanding the work first, draw the logic, identify normal and abnormal cases, then the tool become easier to learn. Now, okay, now this slide is about attended versus unattended automation. Uh, the difference help us to choose the right deployment model, whether you choose attended one or whether you choose unattended attention. Okay, attended attention runs with a human user, right? The board supports the person while they are working. For example, imagine a student service officer is responding to student requests. When the officers opens a student record, an attended bot can automatically collect related information from multiple systems and display it on the screen. The human still talks to the student and make decisions, but the board reduces repetitive searching and copying. After the boards are useful in front office work, help desk, call centers, administrative supports, they are usually triggered on demand. A person clicks a button, start the board, review the result, and continues. The risk is generally lower because a human is present, but design quality still matters. Now, this is attended automation. Now, unattended automation runs without a human present. It may run overnight on a schedule or through a QE. For example, every night at 1 a.m., unattended automation may download reports, validate records, update a database, and email a dashboard to managers, right? This is useful for back office work where tasks are repetitive and can be processed in batches. But unattended boards require stronger monitoring. They need secure credentials, queue management, logs, exception, routing, and ownership. If an unattended bot fails silently, it can create serious problems. For example, if a bot stops processing student applications and nobody receives an alert, delays will accumulate. This is why uh, unattended boards need credential queues, logging, exception routes, and clear ownership. Ownership means someone must be responsible for the board after deployment. Who checks the log? Who updates it when the application changes? Who handles exceptions? Who approves changes? For a student, the practical lesson is the same process may need different automation models depending on the context. If human judgment is needed frequently, attended automation may be safer. If the task is stable, rule-based, and high-volume, unattended automation may be appropriate. Now, the professional RPA design always considers people, risk, and support. Now, this is called as RPA cycle, how the process starts and what are the steps. Okay, the first step we have discover, then we go for assesses, design, build, test, deploy, and monitor. Okay, this is like a life cycle and it shows the automation is not just building a bot. Building is only one step. The full life cycle begins before deployment and continues after deployment. The first step is discover. Here we observe the process, we talk to users, collect examples, watch how work is done, and understand pain points. For example, if we want to automate certificate request, right? We should sit with the staff and ask, how does the request arrive? What documents are needed? What system is checked? And what is the common problem? The second step is assesses. Not every discovered process should be automated. We assess volume, frequency, rule, clarity, data structure, risk, benefit, and feasibility. A process with high volume and clear rules is stronger than a process with low volume and many exceptions. The third step is design. We draw the workflow, define triggers, inputs, outputs, rules, exceptions, path, and logs. This is where professional thinking appears. A well-designed bot is easier to build and maintain. The fourth step is build. Here we use the selected tool such as Power Automate, UiPath, or Automation Anywhere to create the automation. But remember, building without a design is risky. The fifth step is test. We test normal cases, missing data, unusual formats, system delays, and failure conditions. Testing builds confidence. The sixth step is to deploy. The board goes into use, but deployment should include permissions, documentations, user training, and support argument. The seventh step is monitor. This is often forgotten actually. A board is not finished after deployment. Applications change, data changes, rules change, and user discover new exceptions. Monitoring helps us improve and maintain reliability. Now, uh, if you cannot draw the process, you are not ready to automate. This is powerful professional principle. The deliverables are process, map, automation, brief, risk log, test cases, deployment plan, and KPI dashboard. These documents make automation credible. Now, this is the tool and platform what we are using. For example, we have UiPath, how UiPath automation anywhere and Microsoft Power Automate. Here we discuss these platforms. At this stage, students often become excited because tools make automation visible. But I want to repeat an important point. Tools are important, but they are not the whole story. If we understand the process and logic, tools becomes easier. If we do not understand the process, even the best tool, even ChatGPT, we will not save the project if we cannot do the task properly. This Here we are usually these are widely known and we can call as RPA landscape. Each platform has its own ecosystem, strength, licensing model, and learning path. But underneath the interface, many automation concepts are similar. You will find triggers, actions, variables, conditions, loops, exceptions, logs, and monitoring. UiPath are often associated with strong enterprise RPA features, training resources, Studio or Studio X environments, robots, orchestrators, queues, and process mining. Automation anywhere is also enterprise oriented and emphasizes bot lifecycle, cloud native automation, control room, discovery, and scalable bot management. Microsoft Power Automate is very useful in organizations that already use Microsoft 365, Outlook, Excel, Teams, SharePoint, and related services because they already have subscription for this. Now, for postgraduate students, the best strategy is not to ask which tool is best. A better question is which tool fits my process, my organizations, my assets, my security needs, and my learning objective. For a small student project, Power Automate may be easier because many students already know Microsoft tools. For enterprise automation, UiPath or automation anywhere may provide stronger orchestration and governance. For research, they may even build custom scripts using Python, APIs, and workflows engine. A selection committee will also appreciate this balanced approach. We are not teaching students to become button clickers. We are teaching them to become professionals who can evaluate tools based on need, context, and responsible implementation. So in this part, we will understand what to look for in RPA tools, then examine these platforms through a learning lens. Now, uh, uh, this slide explains how to evaluate RPA tools. When choosing a tool, many beginners only look at the visual interface. They ask, is it easy to drag and drop? That matters, but professional tool evaluation goes deeper. We need to consider capability, governance, learning curve, integration, analytics, security, and organizational fit. The first component is design studio. This is where we create workflows. In UiPath, this may be studio or Studio X. In Power Automate, it may be cloud flows or desktop flows. A good design environment allows us to create actions, conditions, variables, loops, and exception handling clearly. The second component is bot runner. The word bot runner, like a Blade Runner, they have movie. Designing a workflow is not enough. Something must execute it. The bot runner carries out the automation. It may run on a user computer, a virtual machine, or a cloud connected environment. The runner must be stable and properly configured. The third component is orchestrator. This is crucial for enterprise automation. Orchestration means scheduling boards, assigning work, monitoring execution, managing queues, handling credentials, and viewing logs. Without orchestration, automation may remain a small person script instead of a scalable organizational capability. The fourth component is connectors. Now, the modern automation often needs to connect with email, Excel, databases, cloud services, APIs, CRM, ERM, and collaboration tools. A platform with strong connectors can reduce development time. The fifth component is analytics. If we cannot measure performance, we cannot improve. Analytics can show success rate, processing time, exception rate, queue status, and bottlenecks. The sixth component is governance. Governance or governance, we can call this. This include roles, permissions, security, audit trails, version control, and compliance. The governance is what makes automation trustworthy. For a workshop, however, the best tool is the one student can access quickly and understand clearly. We do not want students to spend 2 hours struggling with installation. So the practical teaching approach is demonstrate the concept, use simple tools when possible, and make the logic transferable. Now, this is about UiPath, and this UiPath as a common enterprise RPA pattern. Okay, now I'm not presenting UiPath as the only solution, but it is useful because its component help us understand how many enterprise RPA systems are structured. The first component is Studio or Studio X. This is the design environment. Studio is often used by developers or technically confident users, while Studio X is designed for business users with less coding background. In this environment, we build the workflow. For example, we can design a process that opens an Excel file, reads each row, checks a condition, sends an email, updates the row, and logs the result. The second component is robots. A robot executes the automation. It can be attended or unattended. An attended robot works with a user, while an unattended robot runs independently without any human involvement. For example, an attended robot might help an employee process the case while the employee is not present, and while the employee is present, not is present. An unattended robot might run every night to prepare robots without human intervention. The third component is orchestrator. This is very important to enterprise settings. Orchestrator manages schedules, queues, assets, credentials, logs, and monitoring. Let us take a queue as an example. Okay, if we have 1,000 students records to if 1,000 student records to process, we can place them in a queue. The robot processes each item, marks it successful or failed, and logs the reason. This makes automation more reliable and auditable. The fourth point is process and task mining. These tools help discover and prioritize automation opportunities. Instead of guessing where time is wasted. Process mining can analyze system logs to show actual process patterns. Task mining can observe user level actions to identify repetitive tasks. For students, the key learning is not to memorize product names. The key to understand the pattern. First, we have a design, then we go for run, manage, monitor. In any professional automation environment, we need these layers. If we do not have a mature solution, if we only run a board without governance, we create risk. UiPath help us understand the enterprise mindset. Uh, you are seeing my screen, Professor. I just pause for a while. I see it is audible. Everyone is listening. You are
Yes,
hearing my
doctor, you're
voice?
audible. Yeah,
Okay,
it's
okay,
clear,
okay.
doctor.
Okay. I continue. Thank you. Okay, now this is interesting. Okay, we have here boards discovery documentation. Okay, this slide present automation anywhere as another major RPA platform. First we discussed by UiPath. Now the second is automation anywhere. It is inside of RPA platform, and the aim is not to sell a tool but to understand the structure and thinking behind enterprise automation platforms. Okay, now automation anywhere's automation 360 is commonly discussed in terms of board creation, board execution, central control, discovery, and governance. uh, the slide here we called is board creator or board agent concepts, which support building and running automation. This is similar to the general idea of designing a workflow and then executing it through a bot environment. Okay, now the control room is an important concept here as well. It provides central management. For example, in an organization, we do not want every bot running randomly or on different computers without supervision, right? The control room help manage deployment users, schedules, credentials, roles, and monitoring. For example, if a bot is processing invoice records every day, the organization needs to know whether it succeeded, failed, or encountered exceptions. Central control gives visibility. Also, this slide also mentioned process discovery. This is increasingly important because organizations often do not fully know how their processes are actually performed. Official process documents may say one thing, they say, but real staff behavior may be different. The process discovery can help reveal hidden work, repeated actions, bottlenecks, and automation opportunities. Automation anywhere is often suitable when organizations need scalable back office automation. Think of HR onboarding, finance processing, compliance reporting, customer data updates, or service request routing. These processes often involve high volume, repeated rules, and multiple systems. For hands-on example, imagine a finance office receive a PDF invoices. Document automation can extract supplier name, invoice number, date, and amount. The bot validates the data against a purchase order system, enters approved invoices, and send exceptions for human review. This combines document processing, rule validation, bot execution, and governance. Now, for the student, I say that the learning point is that enterprise RPA requires more than a building a bot. It needs discovery, build, run, and govern. That is why I choose from starting workflows from discover, build, run, govern. This is a professional life cycle mindset. Now, this slide introduces Microsoft Automate. Many student and organizations are already familiar with Microsoft tools such as Excel, Outlook, Teams, SharePoint, and OneDrive. This makes Power Automate very practical for learning and for real workplaces scenarios. For example, here Power Automate includes cloud flows and desktop flows. A cloud flow is usually triggered by an online event. For example, when a new email arrives in Outlook with a specific subject, the flow can save the attachment to OneDrive, update an Excel table, send a Teams notification, or start an approval process. This type of automation is useful because many administrative processes already happen inside Microsoft 365. A desktop flow automates action on a computer. For example, if a legacy desktop application does not have an API, a desktop flow can open the application, click fields, type values, copy information, and save results. This is closer to classical RPA because it works with the user interface. The slide also mentioned here attended and attendant RPA. In Power Automate, the deployment models depends on the scenario and licensing. For student learning, we do not need to go deeply into licensing, but we must first understand the real implementation always includes access and cost considerations. The strength of Power Automate is its ecosystem. If the organization already uses Microsoft 365, then connecting Outlook, Excel, Teams, SharePoint, forms, and approvals can be very effective. For example, a simple student activity could be when a Microsoft form is submitted for workshop registration, the flows record the response in Excel and check whether the email is valid, send a confirmation email, and notifies the coordinator in Teams. This is very good teaching platform because student can understand triggers, actions, conditions, variables, approvals, and logs without needing very complex setup. However, we must also be careful. A flow that handles personal student data must follow privacy and access rules. The professional lessons here, the Power Automate is powerful when the process lives inside the Microsoft ecosystem, but like every tool, it must be designed with governance and reliability in mind. Now, okay, this slide compares actually UiPath, Automation Anywhere, and Power Automate from a student learning perspective. The purpose is not to declare a winner. Instead, we compare them to understand our transferable concepts. The first comparison is learning in tree. UiPath has Studio X and Academy resources, right? That help beginners. Automation Anywhere has Automation 360 learning resources. Microsoft Power Automate has Microsoft Learn and often feels familiar to students because they're already using it with the help of 365 or Outlook. For teaching, access matters. If a student cannot access the platform easily, then the learning experience becomes frustrating. The second comparison is deployment. UiPath uses robots and orchestrator. Automation Anywhere uses bot, agent, and control room. Power Automate uses cloud and desktop flows. Although the names are different, underlying ideas are similar. Design the automation, execute it, manage it, and monitor. The third comparison area is strength. UiPath is strong in enterprise orchestration. Automation Anywhere is strong in discovery and scalable boards. Power Automate is strong in the Microsoft ecosystems, but these strengths depends on context. For example, if an institution relies heavily on Outlook, Excel, Teams, and SharePoint, like OTAS, Power Automate, and Dhofar University even, then Power Automate may be very helpful and practical. If an organization wants large scale bot governance, UiPath or automation anywhere may be more suitable. The fourth area is watch out. Every platform has limitations. Licensing and setup can be challenging. Enterprise environments require planning, access permissions, environment configurations, and data security must be considered. This is important because students must understand that professional automation is not only a classroom demo. The teaching approach on this slide is very important because first we go demonstrate the common pattern. First we have trigger, action, condition, loop, exception, log. These 6 concepts are transferable across tools. For example, in Python, Power Automate, UiPath, or Automation Anywhere, you still need to know what starts the process, what actions, what action occur, what design decisions are made, what repeats, what happens when something fails, and what evidence is recorded. So for students, the goal is tool literacy, but plus conceptual maturity. Now, okay, this slide is about practical delivery. In an online workshop, we must design the session realistically. Not every student may have the same laptop, right? Software access, license, internet speed, or installation permission. So the workshop should not depend entirely on everyone installing a complex RPA platform with this session. Instead, we are using layered approach. The first requirement is simple. Student join with a laptop browser like you are joining here. This allows them to follow the demonstration, participate in discussion, and complete the process. The second step is that I already share my screen, like for the how platform workflow work, and this is effective because student can see the logic live. For example, maybe in the next seminar we can show simple automation reads data from Excel, check status, send email. Even students do not build it fully, during the session they understand the flow. The third step is that students complete process mapping exercise in parallel. This is very valuable. Instead of only watching, students think actively. They can choose a process such as event registration, certificate request, attendance tracking, or grade sheet consolidation. Then they identify inputs, steps, rules, exceptions, and outputs. The fourth option is hands-on tool use if available. We can use academic or community access to RPA tools, or we can use BPM or simply workflow diagrams. The key point here is that uh, hands-on means you are understanding the process, writing pseudo logic, identifying exceptions, and designing the automation opportunity canvas. For postgraduate students, this is important because real-world automation begins with analysis. Many automation failures occur because people jump into the tool too early. Here, we intentionally make students slow down and think. Uh, how we do it. That's why students should not underestimate simple scenarios first. Well-designed Excel email automation can teach powerful professional concept. For example, we have data validation, conditions, loops, logging, and exception handling. Now, okay. Now, here we move to part 3, business process management or BPM. This is one of the strongest part of the workshop because RPA without without the use of clarity, strongest part, clarity can without the clarity in RPA, it become dangerous. If we automate a bad process, we may simply make bad work happen faster. BPM is about understanding, modeling, analyzing, improving, and monitoring business processes. Business processes is sequence of activities that produces an outcome. In an university example, include student admission, course registration, transcript request, examination scheduling, project submission, attendance reporting, and event registration. They are counted as BPM process. In business, examples include invoice processing, customer onboarding, employee recruitment, and purchase approval. Before automation, we need to ask basic questions. What is the purpose of the process? Who starts it? What data is required? Which systems are involved? Which decisions are made? Where do delays happen? Where do errors happen? Which steps add value and which steps are only administrative burden? Let us use a practical example. Okay, now suppose student request a certificate. The process may begin with an email or an online form, right? Staff check student identity, academic status, payment status, and approval requirements. Then they prepare the certificate, send it for signature, update a record, and notify the student. If we automate without understanding these steps, we may miss critical controls. For example, a board may send a certificate without proper approval if the rule is poorly designed. This is why clarity comes first. BPM help us decide whether RPA is appropriate or not. Sometimes the solution is not automation, but process redesign. For example, if students submit requests in many formats, the first improvement may be standardized digital form. Once the input becomes structured, automation becomes easier. For a selection committee, this section demonstrate the workshop is academically and professionally grounded. It is not a tool tutorial only. It teaches students to analyze systems, communicate with stakeholders, and design responsibly digital transformation. Uh, in this slide, we have the core messages here. Before we automate the work, we must understand the work. Okay, now this is the basic of BPMN. Okay, this slide introduces BPMN, which stands for Business Practical Model and Notation. Here BPMN gives businesses and technical people a shared language to describe processes. This is important because automation projects usually involve different stakeholders, managers, staff, developers, students, IT teams, and sometimes customers. If everyone describes the process differently, confusion happens. BPMN uses symbols to represent process elements. We do not need to learn every advanced symbol today. For this workshop, we use just enough notation for clarity. The slide show basically the elements we are using. For example, we have the circle part, we use a start and end like a flowchart. Then we have activity shown by the rectangular shape, and then we have gateway, data, and flow. Okay, start event shows where the process began. For example, a student submits a request and activities are tasks such as check student ID or update Excel sheet. A gateway represents a decision such as payment complete? If yes, the process continues. If no, the process moves to an exception path. Data represents input or output such as form, spreadsheet, PDF, or database record. Flow shows the direction from one step to another. Let us take a simple example. A student registers for a workshop. The process begins when the registration form is submitted, right? The system checks whether the email is valid. If the email is valid, it checks whether the student status is active. If both conditions are true, the student receives a confirmation email. If not, the case goes to manual review. This can be drawn clearly with BPMN. Here we are not just enough using a notation. For clarity, a clean process map is better than a complex diagram nobody can maintain. This is very important teaching point. Sometimes for people create beautiful but overly complicated diagrams, right? The real purpose of a diagram is communication. If staff and students cannot understand it, It is not useful. Now, for the students, BPMN is valuable because it helps you move from informal thinking to a professional documentation. It also helps when writing project reports, proposals, thesis, and system designs. A clear process map can become the foundation for automation, testing, and evaluation. Now, this slide introduces a very important concept, ASIS to TOBE. ASIS means the current process, how work happens today. TOBE means the improved future process, how the work should happen after redesign or automation. The ASIS flow on the slide includes steps such as receiving a request, checking data, manual entry, verification, and sending emails. This is very common in real organizations. Many processes have manual handoffs, repeated checks, slow response times, and human dependent follow-up. The problem is not always that staff are inefficient. Often the process itself is not designed well. For example, imagine an event registration process. Students can send their details by email. The coordinator copies names into Excel, checks duplicates manually, send confirmation emails one by one, and later prepares an attendance list. This works for 10 students, but for 300 students, it becomes a slow and error prone. That is the ASIS process. The TOBA process redesigned the work. Instead of email-based registration, the students fill a digital form. The board validates required fields, checks duplicates, updates the system, send automatic confirmation, and places incomplete cases in an exception queue. Staff do not disappear. They focus on exceptions, special cases, student questions, and quality checking definitely. This is the professional value of automation. We do not simply copy the old processes into a board. We ask whether the process can be simplified. Maybe some steps are unnecessary. Maybe data should be collected earlier. Maybe approvals can be standardized. Maybe manuals, emails can become template. This slide says also automation should improve the process, right? Not freeze bad habits. This is a powerful message. If the current process is confusing, automating it may make confusion faster. So before designing a board, we should ask what should change, what should remain human, what should be automated, and what should be eliminated. For the student, we can call that this ASIS to TOBE thinking is useful in research and industry. It shows maturity because you are not only using technology, you are improving systems. Now, this slide answer our practical questions. How do we know which process is suitable for automation? The answer is to use a disciplined screening lens. We do not choose processes randomly. We evaluate them. The first criterion is high volume and frequent repetition. If a task happens once a year, automation may not be worth the effort. But if it is happened daily or weekly with many records, automation becomes more valuable. For example, processing hundreds of student registration records is a stronger candidate than preparing one special report per year. The second criteria is stable rules and clear decision logic. RPA works best when the rules are known. For example, if payment status is complete, send confirmation. If is incomplete, send reminder. If a student ID is missing, route to manual review. If rules are unclear or depend heavily on human interpretation, automation becomes risky. The third criterion is structured input or predictable screens. Boards need reliable input, Excel files, online forms, database tables, and standardized emails are easier than messy handwritten notes on unpredictable message. formats, if data is unstructured, may need AI or document processing before RPA. The fourth criterion is low exception rate or manageable exception paths. No process is perfect. There will be always be missing data, duplicate records, system delays, and special cases. But exceptions must be manageable. If 70% of cases require manual judgment, full automation may not be useful. The fifth criterion is measurable benefit. We must first define value, time saved, errors, reduce faster response, better compliance, improve satisfaction, or reduce backlog. Without measurement, automation becomes a nice demo, but not a strong business solution. Let us apply this to a university example. For example, grade sheet consolidation may be repetitive, structured, and measurable, but it has high sensitivity. So automation may help prepare data, but human review remains necessary. Event registration may be lower risk and easier for registration may be lower risk and easier for student practice. Certificate request may require a stronger approval control. This screening lens teaches student professional judgment. For example, RPA is not about asking, can we automate? It is about asking, should we automate and how safely? Now, this slide is one of my favorite slides because it teaches maturity when not to automate first. Many people think automation expertise means saying yes to every automation request. Actually, a responsible automation professional sometimes says not yet. The first case is when the process is unstable or changes every week. If rules, screens, forms, or approvals keep changing, the board will require constant maintenance. In such cases, we should stabilize or redesign the process before automation. Otherwise, the board becomes fragile. The second case, when input data is unstructured and cannot be reliably interpreted or understand or read. For example, if a request arrived as fast as a free text, emails in many different styles, a rule-based bot may struggle. We may need to standardize the input through forms, tablets, or AI assisted classification. But even AI needs validation. The third case is when human judgment, empathy, or legal accountability is central. For example, student appeals, disciplinary decisions, medical decisions, visa related judgment, or sensitive HR cases should not be fully automated without human oversight. Boards can support documentation, routing, and reminders, but final judgment should remain human. The fourth case is when the underlying system will soon be replaced if an organization is already moving to a new student information system or a finance system. Building a complex board on the old system may waste effort. In that case, we may create temporary automation only if the benefit is urgent and the scope is limited. The fifth case is when risks are high and controls are not ready. If credentials are not secure, logs are not retained, data privacy is unclear, or exception handling is weak, automation should pause. A board that processes sensitive data without governance can damage institutional trust. The word pause on the slide is important here. Pausing does not mean rejecting innovation. It means preparing better. We can say, let us first standardize the form, then define rules, improve data quality, assign ownership, and then automate. For the student, this is valuable professional skills. Employers and academic committees value candidates who can balance enthusiasm with responsibility. Intelligent automation is not only about speed, it is about trustworthy improvement. Now, this slide introduces the automation opportunity canvas. This is a practical tool student can use immediately. The purpose is to organize thinking before building anything. In real organizations, many automation ideas fail because people begin with a vague statement. Let us automate this. But what exactly is the process? Who owns it? What are the inputs? What are the rules? What are the risks? The canvas forces clarity. The first item is process name. This should be specific, such as workshop registration confirmation or student certificate request tracking. Avoid vague names like student service automation. The second item is honor. Every process needs an owner. If nobody owns the process, nobody will maintain the boat. The owner may be coordinator, department office, finance team, or academic unit. The third item is trigger. What starts the automation? A new email, a form submission, or a Google form, a schedule time, a file upload, a button click. Now, next are inputs and systems. Inputs may include Excel files, forms, PDFs, emails, databases, or web portals. Systems may include Outlook, SharePoint, student information systems, ERP, CRM, or local databases. Then we define rules. For example, if status is complete, send confirmation. If data is missing, route to exception. If duplicate exists, stop and alert. Then we list exceptions: missing emails, invalid ID, duplicate request, system unavailable, wrong file format, incomplete payment. These must be identified before building. Then we consider risk. Does the process handle personal data? Are approvals required? Could a wrong email cause harm? Could data be overwritten? Then we define KPIs. How will will we measure success? Time saved, error reduction, faster response, lower backlogs, fewer manual corrections. Finally, we evaluate benefit, effort, and decision. Should we automate now, redesign first, or leave it manual? Thus, this slide gives you student examples: certificate requests, event registration, or grade sheet consolidation. These are excellent because students can relate to them. By filling the canvas, students learn to think like automation consultants, not just tool users. Now, in this, now we begin part fourth, the hands-on automation logic section. This is where students start thinking like builders, but the slide title is very important. I choose it here: design a simple bot before touching a complex platform. This means we should first understand the logic on paper or through a simple diagram before clicking inside any software. In many technical workshops, people jump into the tool immediately. The instructor says, click here, drag this activity, connect this block. The student may follow, but afterward they do not understand why they did these steps. In this workshop, we reverse the approach. We first design the logic, then the tool becomes a way to implement that logic. Board is a sequence of instructions. For example, read a row, check a condition, perform an action, log the result, move to the next row. This can be written as a pseudocode, drawn as a flowchart, model in BPMN, or build an RPA platform. The concept is same. Let us take a simple example. Suppose we have an Excel sheet with student names on it, email addresses, registration status, and payment status. We want the board to send confirmation emails only to students whose records are complete. The logic is straightforward. Open file, read first row, validate fields, check status, send email if valid, update now, log result, repeat until the last row. But even this simple example has practical issues. What if the email address is missing? What if the status columns contains complete, then completed maybe, and then done? Is different styles, right? What if two students have the same ID? What if Outlook is not connected? What if the file is locked? These are hands-on realities. So in this section, we focus on practical automation, logic, inputs, validation, decisions, loops, outputs, and exception handling. These are the building blocks of every RPA project. Now, this slide presents a hands-on scenario. For example, automating a simple student registration confirmation process. I choose this example because it is familiar to students and university staff. It is not too sensitive, but it contains enough logic to teach real automation concepts. The input is an Excel list of students registered for a workshop. The list may contain student name, student ID, email address, program registration status, and payment or approval status. Excel is common in many organizations, so this example is realistic. The rule is send confirmation only if the email is valid and the payment or status complete. This rule teaches conditional logic. A board should not blind send emails to everyone. It must check whether the record meets the criteria. If the email is invalid, the board should not send. If the status is incomplete, the board should not confirm. Instead, it should place the case in an exception queue. The action is write command, send an email, or place the case in the exception queue. This shows two paths: normal path and exception path. Normal path means the case meets the rule. Exception path means something needs to review. Now, the output is summary of report of the coordinator. Now, let us imagine the live explanation. I would say students look at this Excel file. Each row is one student. The bot will process rows one by one. For each row, it will ask, is the email present? Is the email format valid? Is the status complete? If yes, send confirmation. If no, write the reason in the exception column. This simple scenario that teaches many more concepts like data, input, validation, rules, action, logging, exceptions, and reporting. It also shows that automation is not only technical, it supports service quality, students receive faster confirmation, staff reduce repetitive work, and coordinator has better visibility. Now, this is called as logic in a simple workflow. For example, this is also simple logic. We start from start, read row, check status, send email, write log, next row. The decision point is valid. If yes, follow the normal path. If no, place it in exception queue. This is the heart of automatic logic. For example, the first step here, start. Every automation needs a clear start. Is it manually started by the coordinator? Is it scheduled daily, or is it triggered when a file is uploaded? Without a clear trigger, the automation is not operationally reliable. The second step is read row. The board reads one record at a time. This introduces the concept of loops. If there are 100 students, the board does not need 100 separate instructions. It repeats the same logic for each row. The third step is check status. This is a decision rule. The board checks whether the required conditions are satisfied. For example, email is not empty, status equals complete, and student ID is present. If the record is valid, the board follows the normal path, send email. The email should be based on a template. Okay. Here, what matters here, the main thing, readability matters. If your supervisor, manager, or colleagues cannot understand your workflow, it will be difficult to trust. Professional automation should be transparent. This is for students. Now, this slide focuses on data validation and with protect the process. Actually, most bot failures begin with poor input assumptions. Uh, Data validation is one of the most important parts of automation. Many bot failures do not happen because the bot tool is weak. They happen because the data is not what the designer expected. The first validation step is to check required fields before processing. In our student registration example, required fields may include student name, email, ID, and status. If any required field is missing, the board should not proceed blindly. It should record the issue and send it for review. The second step is to normalize dates and names and email formats. Data often comes in different styles. One person writes completed, another writes complete, another writes done. A human can interpret that easily, but a board needs a consistent rule. Normalization converts data into standard formats. The third step is to use reference lists to avoid spelling and category errors. For example, program names, course codes, department names, or status values should be selected from a control list where possible. This improves reliability. The fourth step is to log every skipped or failed record with a reason. This is critical. If the board skips the student because the email is invalid, the coordinator should know. Silent skipping is dangerous because people may assume everything was processed. The fifth step is never silently override important business data. This strong governance principle. If the board updates the record, it should do carefully. It should not override human inter notes, approvals, or sensitive information without permission. Uh, for I would here what we learn here, validation in this slide. Validation protects the process, the user, the organization, and the bot's credibility. Now, this slide explain exception handling. This is where automation becomes professional. A beginner may design only the happy path. If everything is perfect, the boat works, but real life is not perfect, right? Professional automation must handle what goes wrong. The first type is business exception. This means the case does not meet a business rule. Uh, for example, a student registration record has an incomplete status, missing payment confirmation. Now, the second step is system exception. This happens when the application, browser, network login, or file system fails. For example, Outlook is not responding, the Excel file is locked, and web page layout change. Now, the third concept is human in the loop. This means uncertain or sensitive cases are routed to a person. Human in the loop is very important in responsible automation. For example, if the board cannot decide whether a student's status is valid, it should ask a coordinator instead of guessing. The fourth point is to retry logic should be limited and locked. If a website fails once, the board may retry after 30 seconds, but it should not retry forever. Unlimited retry can create system load, duplicate action, and hidden failures. The fifth point is the escalation routes must be clear before deployments. Who received the alert? Who checks the exception queue? Who corrects data here? Who start the boat? These are the fundamental questions in this category. In this, I say to the students, exception handling is a sign of maturity. A good automation project is not judged only by whether it works. It is judged by how safely and visibly it fails. Now, this slide presenting a testing checklist. Okay, testing is where confidence is built, right? A board may look impressive in a demo, but if it has not been tested properly, it cannot be trusted. In academic project, testing also strengthens the quality of your report or thesis because you can show evidence. The first test, for example, is a happy path. This is the standard complete record. For example, student row has name, valid email, complete status, and no duplicate. The bot should send confirmation and update the record and log success. Second test is boundary case. Boundary cases include empty, long, or unusual fields. For example, a very long student name, a name with special characters, or missing optional fields. Boundary testing helps us to see whether the boat is too fragile. The third is exception case. In this case, anything that is missing or invalid. For example, no email address, invalid email format, or incomplete status or duplicate ID. The board should not crash. It should route the case to exception and write the reason. The fourth test is the system case. This test what happens if the app times out, the file is locked, the browser is unavailable, or the network is too slow. The fifth test is audit case. This checks whether the log is complete and readable. The log should answer what record was processed, when was action was taken and what was the result. Now, here the takeaway is that this simple activity teaches software testing, quality assurance, and professional responsibility. Now, the part 5, this is the part 5, we call this governance and impact. This section moves us from building automation to managing automation responsibly in real organization. Our technically working board is not enough. The board must be useful, safe, accountable, secure, measurable, accepted by people. Governance means the rules, roles, controls, and monitoring around automation. Who can create bots? Who approves them? What data can they access? Where are passwords stored? How are logs reviewed? What happens if the bots makes an error? Who's responsible for maintenance? These are governance questions. Now, now, benefit of RPA implementation. Now, this slide explains the benefits. For example, many people first think of speed, and yes, speed is important, but the value of RPA is not only speed, it is also reliability, consistency, compliance, service quality, and human capacity. The first benefit is speed. Bots can process routine cases faster than manual work, especially when the task involve repetitive digital actions. For example, sending 200 confirmation emails manually may take hours. A bot can do it much faster before provided with the data and it is clean. The second benefit is accuracy. Humans can make mistakes when copying data repeatedly, especially under time pressure. A bot follows the same rule consistently. If designed properly, it can reduce routine errors such as wrong copying, missed rows, or inconsistent email templates. The third benefit is compliance. Bots can create logs and repeatable actions. This means we can show evidence of what happened in regulated or academic environments. Audit trails are valuable. For example, we can show when a record was processed, what decision was made, and why a case was sent to exception. The fourth benefit, service. Faster response improve user experience. Students, customers, or staff do not like waiting for routine confirmation. If the automation handles simple cases quickly, humans can focus on complex cases. The fifth benefit is capacity. This is very important. RPA should not framed only as replacing people. A better message is that automation increases human capacity. Staff can spend less time on repetitive tasks and more time on analysis, advising, problem solving, and improvement. Now, for the student, the key communication skills when presenting an automation proposals, explain benefit in business language, cycle time, error reduction, auditability, service quality, and staff capacity. This is stronger than saying only we build a bot. Now, the common challenges why RPA project fails. It is very important to teach challenges because students should not leave thinking RPA is always easy. RPA project can fail when organizations treats both as isolated shortcuts. The first challenge is poor process selection and weak requirements. If we choose the wrong process, the board will not deliver value. Now, the second is fragile UI automation. When screen change, RPA often works through user interfaces. If a button moves, a web page layout changes, or an application updates, the bot may fail. The third challenge is lack of ownership after deployment. Many organizations build a bot and celebrate, but nobody is assigned to maintain it. Then when the process changes, the bot breaks. Ownership must be clear. Process owner, technical owner, support contact escalation paths. The fourth challenge is credential, privacy, and audit weakness. Bots need access to systems, right? If passwords are stored insecurely or shared carelessly, there is a major risk. If logs contain too much personal data, that is also a risk. Security privacy must be designed from the start. The fifth challenge is scaling too fast without governance and reusable standard. A small board may work well, but if every department builds board differently without standards, the organization may face chaos. Definitely. Now, okay. This slide presents a simple governance model with 5 elements: honor, access, loss, control, and review. Even a student project should model responsible automation. Governance does not have to be complicated, but it must be present. The first element is honor. The process honor approves the scope. For example, if we automate workshop registration, the postgraduate or coordinator may be the process honor. The second element is access. Board should use least privilege credentials. This means the board should only have the access it needs or not more. Yes. The third element is logs. The audit trail should be retained. Logs show what the board did. A good log may include timestamp, record ID, action taking, result, exception reason. Now, the fourth is control. Exception should be reviewed. If the board sent 20 cases to exception, someone must check them, right? The fifth element is review. The board should be monitored after go live. The process change, data formats change, user needs change. Review ensures that automation remains useful and safe. Now, for the students, takeaway, I just say this governance model can be included in project reports. It shows that your automation is not just technically interesting, but professionally responsible. That is exactly the mindset needed for digital transformation. Now, this slide focuses on security and privacy. Automation is powerful because it can act across systems, but that also means it can create risk if not controlled. A board may access file, database, email, student records that create a security issue. The first point is here, role-based access and avoid shared password in scripts. A board should not contain plain text password. If a password is written inside a script or workflow, anyone who sees the file may reuse it. Professional platforms provide credential vaults or secure assets. Even in student projects, we should practice good habits. The second point is to store credentials securely, not in plain text. This is especially important for unattended boards because they run without human present. Now, third is to minimize personal data and keeps logs appropriate. Logs are important, but they should not expose unnecessarily personal information. For example, instead of logging full sensitive data, we may log record ID and status. Data minimization means collecting and storing only what is needed. The fourth point is to validate outputs before automated emails or update are released. A board that sends wrong emails can create confusion or privacy issues. The fifth point is to keep human accountability for sensitive decisions. Automation can support decisions, but sensitive decisions should not be fully delegated to boards without review. The word trust appears here. Trust is essential. Trust user trust automation when it behaves predictably, transparently, and safely. If a board makes unexpected or unexplained errors, trust disappears quickly. Now, uh, this slide contains how to measure automation impact. This is very important because automation should be evaluated with evidence, not with excitement. A demo may look impressive, but we need numbers and feedback to show real value. The first KPI is cycle time. This measure how long it takes to process one case. Now, the second KPI error state. This measure rework or correction. For example, how many emails were sent with wrong names. The third KPI is throughput. This measure cases per day. A board may process more cases in less time, especially for high volume tasks. For example, a coordinator may process 50 registration manually, while a board can handle 500 standard cases with proper validation. The fourth KPI is exception rate. This is percentage of cases needing review. Exception rate is not bad by itself. It gives insight. If 40% of cases go to exception because data is missing, then the registration form needs improvement. The fifth KPI is user satisfaction. This can include staff feedback and student feedback. Did student receive faster response? This staff feel supported? Did the board reduce stress or create confusion? The sixth KPI is compliance, such as audit completeness. Did every process record leave evidence? Can we trace actions? Are approvals documented? Now, for the students, I say KPI-based registration evaluation can strengthen methodology and make the project publishable or industry relevant. Now, this slide places RPA inside modern IT architecture. This is modern. This is important because RPA should not be seen as an isolated tool. It works best when it cooperates with form, business, APIs, databases, etc. How we start the process: first we have user form, then we have RPA board, then basic business app, API, DB, and dashboard. Let us explain. I take example here. Our students submit a request through a form. The RPA board reads the submitted data. It checks or updates a business application. If an API or database is available, the automation can exchange data directly. Finally, result appear on a dashboard. This is how it done. Now, okay. This slide introduces the new era of intelligent automation. Traditional RPA follows rules. It is very useful for structured, repetitive tasks. Combining the RPA with AI, process mining, document intelligence, analytics, and human in that loop review. This combination is often called intelligent automation. The first element here is process mining. Process mining helps discover what actually happens in a process by analyzing system logs. For example, an organization may believe that invoice approvals takes 3 steps, right? But process mining may reveal many variations, delays, rework loops, and exceptions. The second element here is document AI. Many business processes involve documents, right? Invoices, certificates, forms, IDs, contracts, and reports. Traditional RPA struggles if data is trapped inside unstructured PDFs or scanned images. The third element is LLM copilots. Large language models can assist with summarization, drafting, classification, and exception handling. For example, an AI assistant may summarize student emails and suggest categories. However, we must be careful. LLMs can make mistakes, so sensitive outputs need human review. The fourth element is human review. This is not a weakness, actually, it is a strength. Human judgment keeps accountability. Bots and AI can support routine processing, but people handle uncertainty, ethics, exception, and final decision. Now, this is second last slide. Okay, this slide presents the student capstone activity. The goal is the goal here is for each group to design one practical automation proposal. This is where students apply what they learn. The first step, how to do it? The first step, to choose process from university, healthcare, banking, HR, or public services. I encourage students to choose something familiar. Familiar processes are easier to analyze. For example, university processes include certificate request, lab booking, attendance reporting, event registration, thesis submission, tracking, and student feedback analysis. The second step is to map the ASIS process and identify pain points. Students should draw the current process in 5 to 7 steps. Where does delay happens? Where do error happens, right? The third step is to select the automation level, assistive, partial, or end-to-end. Assistive automation supports a human user, as the name suggests. Partial automation handles standard cases but leaves exceptions to people. End-to-end automation handles the full process, but this is only appropriate when risk is low and the rules are clear. The fourth step is to define data inputs, rules, exception, governance, and KPIs. This is the professional code. What data comes in, what rules are applied, what exception may occur. The fifth step is to present 2-minute automation pitch. This is very important for postgraduate students. Technical ability alone is not enough. You must know this point before designing the real problem. A good pitch includes problem, process, automation idea, expected benefit, risk control, and KPI. Okay, let us imagine certificate request automation. Their pitch could say, currently requests are handled manually by email. We propose a form-based process with bot validation, status tracking, and automated automation. Uh, Standard cases are processed quickly, while incomplete cases go to staff review. Success will be measured by cycle time reduction and exception rate. Now this is second last. Okay, this slide gives student realistic 90-day roadmap. 2-hour workshop can inspire oriented student. In, for example, in week 1 to 2, students should learn concept. This include understanding RP definition, board types, BPMN basics, triggers, actions. At this stage, students should not worry about mastering everything. The goal is vocabulary and mental model. In week 3 to 4, students should map processes, choose 2 or 3 real processes, and draw AS or IS and TOB flows. For example, map workshop registration, attendance reporting, or certificate request. In month 2, students should build mini boards, start simple, use Power Automate, UiPath community. In month 3, students should measure and present. This is where they become professional, measure time saved, errors avoided, exception, and user feedback. The final goal here is employability, right? First, we have process thinking, then we go for automation literacy, then responsible implementation. Now, this is the last slide. Okay, this final slide. In the first takeaway in the slide, start with clarity, with process, with clarity, not tool excitement. This is central message of the workshop. Tools are the useful, but they should not lead the thinking before using UiPath. Automation anywhere or Power Automate. We must understand the process, data, rules, exception, risk, and value. The second takeaway, choose RPA for repetitive, rule-based digital work. RPA is strongest when task is structured, frequent, stable, and measurable. It is not ideal for every problem. If human judgment is central, automation should support rather than replace people. The third takeaway is design for exception, security, and measurable value. A professional board must handle missing data and missing invalid format, system failures, and human review. It must also protect credentials, people, personal data, and institutional trust. And it must be evaluated through KPIs such as time saved, errors, reduced exceptional rates, and user interface. The fourth takeaway is the future is intelligent automation. RPA plus AI plus human judgment. RPA execute routine steps. AI can support document understanding, classification, prediction, and language tasks. Humans provide judgment and language tasks. Humans provide judgment, ethics, empathy, and accountability. The strongest systems combine all of the three. Now, my closing message here, please do not leave today thinking only about boards. Leave thinking about better processes, responsible technology, and how you can use automation to improve real work. This is the real value of RPA. Thank you. Thank you. Anything from the question? And sorry for take your time. I take your time. Long discussion, long presentation.
Very informative, Doctor.
Yeah. Please, questions from students or from teachers? Anything. Because the workshop must be two-way, like they must ask question. Maybe they are exhausted with this 2-hour webinar along with presentation. Yeah.
Listening to you, Dr. Mashallah.
Please, any questions? We have still time. 6 minutes only till 5.
If anyone wants to type the question in the chat also, it's fine.
Okay. Chat, I can see. I stop sharing, or I see the chat. Okay. Chat. Okay, chat. Chat. Okay. Any questions from the chat?
No questions, Doctor. So far, I think it's clear.
If you have something, students can ask anything, like, because they have chat GPT, something like they have a lot of information with AI, anything like AI related something stuff, because everyone using it. They must have it. Because questions are important for reasoning. If we are not asking, then only this is one-way communication, it's not two-way communication, and it's good for a student. Actually, they learn something new, because experience also matters. How we treat them, like how we explain them, that is also important.
Yeah.
Any questions? I see. Thank you so much. And sorry for the long presentation.
It was really very informative, Doctor. You have covered almost everything. Thanks a lot. Chala, Doctor, we have a certificate to be presented to you. It is with our HOD. Inshallah, I will email it to you.
Okay,
and
sure.
if you can share the PPT with us, that will be very much helpful.
Okay, sure. With email, I shared the presentation.
Balaji@utas.edu.om, Doctor. So
okay,
I will share it with all.
Okay. I share with the email, then you can share with all. Yep.
Thanks a lot, Doctor. Thanks a
You're
lot.
welcome. You're welcome.
If there are no questions, I really would like to thank Dr. Qamar for this wonderful and very informative presentation given by him. I have watched a couple of your videos also with the drones, all these things.
Sure.
It was really fantastic. And if you also go to YouTube, you can find videos given by him. It's very informative and useful. Thanks a lot, Doctor, for accepting our invitation and given this wonderful webinar. Thanks a lot, Doctor.
It's my pleasure. Anytime.
Thank you. Thanks a lot.
Thank you so much. Thank you so much for listening. For 2
Thank you.
hours long
Thanks a lot.
presentation.
So, inshallah, we will wind up the meeting, Doctor. Thank you.
Okay, sure. Thank you. Stop sharing. Okay. Can I leave it or wait for a while?
Yes, Doctor. Yeah, please.
Leave it. Okay. Thank you so much. Inshallah
Thank
khair.
you.
Fi amanillah. Assalamu alaikum, everyone.
Salam.